Okay. So we're going through this. I've tried this like 4 times, but like I honestly don't. I never really understood it. Like I tried watching the webinar. I think there's a video. It's like new. It's not this one. There's like a new one. I forget it, but in any case, I couldn't find a good direction on how to do this. So wait, first off, we're gonna do this. Okay. So I have this mold document, and I'm just gonna delete all of this. And instead of this, I actually want to make a cup. So let's just make this like 50. Oops. Wait, 50. Okay. Then we do an extrude. Then we sketch. Okay, great. And now we do this, and we extrude this by 25. Okay. So this is what we're gonna make a mold of. All right. It's a little cup, and I just want to read through this. The problem is, I feel like there's so much prerequisite knowledge. Fully drafted. Okay, a description of how to use each feature. They must be in order. Stock, shut-off surface, parting surface, split. This is the old one, I think. Okay, I haven't seen this one, so maybe we will watch this one. Ooh, I kind of like that. Is that just me, or is that nice? Anyways, intermediate sketches or surfaces. Okay, please report bugs. Okay, blah blah blah. So okay, here's mold stock. Now this one is like probably the easiest one. So if we just go here to, is this the custom features? Mold stock. And then we select our part. Mold surfaces. What does that mean? It's not even in this documentation. Specify an ejection direction by plane or mate connector. So ejection direction. Okay. I don't actually know what that means. I mean, I know what that means. Isotropic shrinkage means it basically comes in from every direction on the normal of the thing, but I only understand that in theory. I don't really understand that in practice. So, ejection thing, let's select a mate connector, and we're going to select this. Okay. It's already at the origin, so we're good. Let's see, does this actually move anything? Okay. Whatever. Whatever. We might as well. Okay, I don't really care about how big the stock is. Obviously, I do when I'm printing it, but all I want is to get the freaking thing done. There's nothing about the theory here. Okay, mold shut-off surface. This custom feature finds the split line on a part. Copies the surfaces and fills any holes or gaps where necessary. Ejection direction is derived from the mold stock feature. The shut-off surface is created on the core side by default. Okay. Help me understand the terminology used when creating molds in CAD software. Hopefully it will teach me what. Okay, yeah, perfect. It's like the first one. Okay, so actually, so the outside of the cup is the cavity, and the core is going to be what goes on top of it. The parting line, the line or surface where two halves of the mold meet. Right. So if we just look at our little cylinder here, they are going to meet on this surface. So we're going to have a cylinder, a box with a cylinder cut out, and that's going to be the cavity. Okay. And then meeting on this, oops, I guess I can't click it. Meeting on this surface, we're going to get where the cavity and the core meet. All right, that checks out. Draft angle. A slight angle usually applied to vertical surfaces of the mold to allow for easy removal of the molded part from the mold. Without a draft angle, the parts might stick to the mold. I think that I saw something about there's a spray that you can put on it, and that will. Okay, here we go. Undercut. Features in the part that prevent it from being ejected from the mold. So if we were to do just hypothetically, let's roll this back, make a plane, make tangent, this, okay, and we were to do this, and we were to just put a hole here. I have to dimension it. I'm obsessed with dimensioning. If we were to do this, and we were to remove, not blind, up to face, and then we select this face. If we were to do this, then the core, either the core or the cavity would need to like fill this in, but then you have really, okay, let's just say that the cavity has this notch in it. Then when you pour it, it will mold around it, and the core and the cavity are going to meet along this cylindrical face, or however you say it. But okay, so then you can get the core out. That's fine. But then the cavity, depending on how much you're willing to flex this, you might not be able to get it out. So this is going to be an example of an undercut feature. So you can't really do that when you mold make. Pins integrated into the mold push the part out after it cools and solidify. Oh, really? Wait, is that like... Now that's interesting. Yeah, so maybe you have to like drill into it. So you drill into the bottom of the cavity, and then you can shove something in to really get it. Yeah, that makes sense. Let's look that up. Mold ejector pins. Okay, I want to see that. Okay. I love videos like this. So, okay, wait. So that's, okay, so this is the part. Oh, interesting. Wait. Oh, there you go. Okay, that's the part that you want. So basically, yeah, these pins allow you to push the part out. That's cool. I didn't know about that. Let's see, what else is there in here? Injection points. Right. Okay, so yeah, okay. Shrinkage allowance. Compensation for the material shrinkage that occurs as the molded part cools. So I think that feature of, where was it? Isotropic. Wait, I don't understand why you would do that here. Why do you do it in the stock part as opposed to... Alright, well, I'll figure that out. Let's see, what else do we have here? Okay, so the schedule for today actually is to buy a silicone degasser. Okay, yeah, oh yeah, mold release. That's what I was thinking of. Okay. Okay, so there's a lot here, but the most important thing I think we understand now, so we can keep going. So we did mold stock, so we have the stock around our part now. Oh, we need to delete. Oh shit. Okay, wait, hold on. Let's just do. Okay. This custom feature finds the split line on a part, copies the surfaces, and fills any holes or gaps where necessary. Okay, so I think if I just do this, I remember that this was not the part that caused me any issue. So now we're doing the parting surface, right? No, we're doing the shut-off surface. Okay, the shut-off. So, okay, so it figured it out. So it automatically figured that out. And then this face, ejection direction, let's see, how do they have it? So they didn't select anything for faces to include or exclude, but they did say inner loops to modify. But that's because they actually have hella inner loops, but we don't have any inner loops, so I think I just leave that. And it had draft angle analysis. I remember I saw that in the webinar, so maybe at some point we'll add a taper to the cup. Okay, so I think that one's pretty straightforward. I think we can just accept that. Now, parting surface. This custom feature extends the shutoff surface to the boundary of the stock part. Okay, cool. I understand that. That makes sense. So basically it's taking... The thing is, this surface is the shutoff surface. So I was saying that I thought it was going to be that top face. All right, well, let's see. Let's see. We're going to find out. Oh, okay. So these are algorithms for how to do the parting surface. Right. Okay. Now I understand. Now that I've taken some time, I understand the difference between the shutoff surface, which is constrained to the mold part, and then the parting surface is the actual step that gets you to have a surface defined for the stock. Okay, so let's do it. Parting surface. Oh yeah, it's already, no, it's here. Parting surface. So it should figure all this out. Default type exclude, extend, extrude. So let's just do exclude. I feel like this isn't right though. Okay, so we did it, but then I'm almost positive that when I do this next one, it fails because I remember having this problem. Interlock. All right, let's just fucking send it because I know this thing doesn't work. Mold split. God, this thing is so fucking annoying. I think it comes back to the fact that I don't understand what the ejection direction is. Because presumably... Alright, let's figure... Okay, wait. Ejection direction is going to be there. What does that mean? Okay, wait. Can we look at this surface? Because what I'm saying is that this surface is probably wrong. So let's look at this. And we're going to change... Wait, can we just delete all this and start over? So I said that the ejection direction is this way. But what does ejection direction actually mean? Is there a doc string? Can we look at the source code or no? Mold stock. Ejection direction. Mold ejection direction. There isn't really a doc string. Huh. Wait, what? Oh, I get it. Okay. That's cool that it's open source. Wait, let's look at some of the examples. Switch cover, that seems pretty basic. Remote, that also seems pretty basic. Alright, let's do that. So what? Okay, that seems like a pretty basic surface. What is this? This is the... Okay, so that's the surface. Okay, so let's just look at what they did in stock. Okay, so they selected their part. The ejection direction is on that. What if we change the mate? What if we change this mate to be that? I don't know what that is gonna do. Okay, so then let's try shut off surface. It still selects this thing, which I don't think is right. I think we need to select, oh my god, faces to include. Here's what I'm gonna do. I'm gonna turn off the mold stock. I don't know where this is coming from. I think I want to include this face, right? Why don't I just put all of them? See if that does something. Okay, well it... Wait, what? Dude, this thing is so complicated. Okay, wait. I guarantee that this thing... But then I go to mold split and it fails. Okay, so I'm just going to fucking I'm just gonna change this. Let's just try, what if we try the bottom? Let's just delete everything. Inner loops equals 0, undercut equals 0. So that's good. No way this works. I just don't understand. I just don't understand how to do it. I'm almost positive that I want it to be the opposite. That I want the shutoff surface to be... Ejection direction? Okay, what do I think ejection direction even means? I think ejection direction means you got the cavity at the bottom and then you got the core at the top. I'm saying that the ejection direction is the direction that the core moves. So the core needs to move up. So that's why I was saying that the ejection direction is this. Okay, this is just a stock thing. The ejection direction is this, which I would assume to be the Z. Well, that is the Z. Okay. So I don't know why that's wrong. Mold surfaces? What do I do there? Maybe I can... Dude, there's no docs on this. What the hell? Mold surfaces. Okay, let's go back to the examples, because clearly I don't know what the frick I'm talking about. Create projected area. I didn't see that. Okay, so wait. Okay, let's roll this back. Oh, wait, make a copy to edit. Hello? Oh, okay. Okay. Alright, so we got this part. It's closed. There's no loops. So it's, in a sense, it's basically just a cup. Well, topologically, it's a ball. It's my fucking balls, bruh. Okay, so let's look at mold stock. So let's roll this whole bar back. I think it does roll the bar back. But, okay, so this is where we're at. And it creates a projected surface. So I didn't do that. What if we just try to do that? Okay. I don't even know what that does. But so I feel like we're at the same spot. These are basically the same, except I have this, which I want to go back here. We're going to just keep doing this over and over and over again until I get it right, because I need to be able to make molds. Okay, so what do they do here? Okay, so what is their ejection direction? It's this. It's the top face. Okay, this is exactly what... Except that is the underside. So maybe the ejection direction is the direction of the cavity? It could be the cavity. So why don't we do that? Wait, no. But the... Let's see here. Let's go back to this. So this is, for us, the inside of the cup. So we want to go here. I'm going to take this, and we're going to go here. And did we select that? Dude, I don't... let's just delete this. Take this. Make a mate connector. Great. Okay, so we're at the same spot. We projected the wrong way, though. We projected the wrong way because they have the projection is on this face. So wait, why don't I take this? Did they select mold feature or oh wait, hold on. Mold surfaces is none. I can't flip the maybe I just need to flip. Let's just try to flip it then. So we're gonna flip this. Okay. Great. So now we have the surface here is okay. I think we're good. Great. So now we go to here and we look at the shutoff surface. So we're gonna do that same thing. And I feel like now maybe I'm on the right track. remote control, mold stock. Okay, so the ejection direction. Okay, so let's just make sure that we get. Okay, so this looks like the same thing because the ejection direction is the back of the cup. So I was just wrong about the ejection direction is the direction that the cavity moves. I don't know why I would be that though. I feel like it makes more sense that it's the other way. I'm ejecting it by pulling it out. But oh, maybe when you're doing injection molding, it's kind of the other way. Because if we go back to this video, the ejection direction is clearly this way. But this would be considered the cavity, right? And this would be considered the core. So it's going in the direction of the cavity. So that sort of makes sense to me. All right, so now he's moment of truth, kind of. Oh, see, it selected something different. It selected all. It's okay. All right, so I think that was the only thing that I got confused on. Ugh, it still didn't fucking work, bro. This shit is broken, man. It doesn't help you at all. Okay, great. So I feel like this one's right. So we did something wrong in parting surface then. Okay, can we look at what the parting surface did? Let's do extend. No, but we wanted to okay, wait. What are the doc strings here? Exclude is what? Oh, exclude isn't even in here. See, that's so nice. Why did that work so well for them? This didn't work well for me at all. I think I wanna go here. Faces to exclude. We're gonna go hide the mold stock and we're gonna select that. I think I'm gonna try that. Now let's look at the parting surface. Now let's do extend. There we go. That looks right. That looks like what I want. Hell yeah, this is gonna work. Check it out. Fuck yes, bro. That's what I'm talking about, man. Let's move this to an assembly so I can look at it. Alright, we did it. We did it. So this is the core and this is the cavity. Alright, so that's how you make a mold in onshape. You just gotta make sure that the ejection direction is right, and you gotta make sure that the surface is right. If the surface is fucked up, then you're toast. Okay, so it did exclude that. So then it takes this face and it extends it out to the edge. The problem, the real frustration is that you get to split and it errors and it doesn't tell you why it errored at all. So you don't really have any, like, feedback. Okay, so now we want to do this draft angle analysis or something. Where was that? Draft analysis. Molds. I wish it played nicer with the wait, let's hide this. Mold split direction is going to be, I can't use a mate connection? How am I going to do it then? Well, that's right. Okay, so it's just you select a face and it takes the normal. And it used to check this. So this is yellow. So yellow, okay. So now what we want to do, actually, is we want to make a new part. So we're going to make a new part studio. And we're going to have a bad taper. So we're going to have we're gonna have a taper that goes like this. So first we're gonna draw a circle and make it 50. Then we're gonna extrude this by 3. Then we are going to draw on here, and we are gonna take a. We're gonna use this. We're gonna draw a line like that, right? And then we need to go down a little bit. Okay, so this is going to be, oh wait, this is a Q. All right, so now, what just happened? There we go. Whoa. This is already a full sketch. Wait, why did I do that? I'm designing this so stupidly. Jesus. We need to do, undo all this. Okay, we want just a line like this. Okay. Yeah, then let's make this like that. And make this like that. And then close it off. This does need to be Q, and then I wish that I could. How do I select other? Not the face. This edge and dimension. What? Why is that like that? Okay, but the point here is that we want to make this angle. Let's make it. Yeah, let's make it 80 so that. And then this is 2. Now the length of one of these needs to be defined. And we're gonna make this, yeah, let's just make it 50. Okay, so now we can revolve this. We can take revolve. Wait, actually if I do this and then I tab, okay, cool. Nice. So now we have this tapered cup. And basically the point is, if the core goes outwards, then you won't be able to pull it out, because you'd have to compress whatever material. You would have to compress You would have to compress the core, basically. All right, so we're gonna do this, and we're gonna try this again. So mold stock. It's gonna be this. The ejection direction is going to be this. Wait, it's gonna be it's gonna be that, but you flip it, and then let's show the projection area. Okay, so this is right. Okay, now let's do mold shut off surface. Okay, we actually want it to be faces to exclude. Let's hide the stock. We're going to take this off. We're going to take this off. It's trying to be too smart for us, but we're trying to do the thing that you don't want. So we want to select this, this, and this. Okay, so let's look at the surface. Oh, but it didn't. Did it just not let me do that? Oh, so that because this is the no. Ugh. How do I deselect it? What the fuck? You can't. You click space and it removes them. What? Terrible. Okay, so there's that. There's that. Why is there 2 of these? Let's just yeah, face of extrude. Okay. I still think it's, because see how this is the only yellow one? If you go back to the first one, can we hide this fucking analysis? let's look at the surface here. Wait, actually, hold on. Let's go back to this. See how this surface is the entire thing? So we need to make that yellow. Otherwise, it's not going to work. At the very least, we need to make the top. Yeah, I'm trying to figure out how we can do this. Ejection direction. Yes, so we want to faces to exclude. What is this red? We want this face. We want that face. That seems right to me, but it's clearly not. Okay, so the so this is clearly not going to work. So maybe it like I don't think it does. I don't think it's like smart enough to like prevent you from doing a is it called a negative draft angle? I don't know if it's a negative or a positive, but basically an undercut part. Now if we think about this, if we flip this upside down, no, I just think that there's no way that you could do this, but surely this thing doesn't prevent me from doing it. I think I just fucked the mate connector. Inner loops 1. What is inner loops? Okay, if I do this, it goes away. And then I do this, it goes away. Now I do this. That doesn't turn yellow. I need that to turn yellow. Make that turn yellow, you dumbass. Fuck. Let's just try to mess with the mate connector then. Well, okay, wait. Let's try it like that. Actually, that might work. I don't know why this is red though. Okay. Let's look at the mold stock. We need to go extend. Oh wait. Wait. So we need to add. In here is an include, turn this off, select this face. Of course it doesn't turn yellow because why would it? Why would it do the thing that I want it to do? Okay. I'm sure that I'm sure that it's like, okay, so let's just try again. And this is going to be the opposite taper. So this is going to be sketch C 50 extrude 3. So we're gonna sketch on this plane. We're gonna make a line. We're gonna take this, use it, make a line from here, here. We're gonna say that's 50. Then we're gonna make a line to here, say that's 2. Then we're gonna make a line to here. Then we're gonna close it off. Then we're gonna make this a Q. Then we're gonna click P to get rid of the planes. Now this is dimension, so that's great. But now we want to do this to here and say that this is gonna be 110. So now we got an opposite taper. So now this should be, if we have a cavity that's in there, you should be able to just. Is it still considered an undercut? It might actually still be an undercut because. No. It depends on which way you do it. Does it? I'm trying to think. This is hard to visualize. All right, so we're going to just take this and revolve it. Revolve. Okay, so now we have this like thing. So now we're going to do mold stock, this part, ejection direction. So the ejection direction is going to be where the cavity's at. So we want it to be here. Let's look at the projected area. Okay, what does that mean? What does that mean? It means that the cavity is going to be here, right? So then we want parting surface. Wait, no, not parting surface, shut off surface. Okay, see, that seems like a solid choice, right? So now we should be able to just go parting surface, extend. Nice. All right, so okay, so we're sort of getting, oh wait, not that. We're sort of getting the hang of this. Okay, so now let's make an assembly. Let's insert part Studio 3. Okay, so now we move this, and this is tapered, and it will just lift out, right? Okay. That makes sense. But now my question is, how do they do it where there is little undercuts? Like, I just want to see what happens if we go to our cup example. Okay. This works, right? So we actually do have 2 things. We can hide this surface. Okay, but we want to go back to can we just duplicate Part Studio? Okay, so what we want to do is we want to go back to here. Great, and then we want to make a plane on here. Okay, then I'm going to sketch on there. Oh, we can't go normal. We want to make a circle like this. And yeah, let's make it 5. And then the distance from here to there is going to be 10. And then we're gonna go like this. We're gonna extrude this, and we need to extrude it actually the other direction. The thing is, there's gonna be a little gap there. So what you want to do second end position, and this is going to be up to face, and then you select this. Wait, I think I just flipped it. this face. Does it make a little bump? It doesn't make a little bump because it goes to, I think. And then here we want this to just be like 5. Okay, so now there's a little bump here. And I don't think that there's a gap there, which is nice. So now let's try to do this again. Okay, so let's import this into a new assembly and take it apart. Or we could actually do section analysis, but let's look at the draft analysis. I don't even know. Oh, let's just hide these maybe. There you go. Okay, so this shows a projection. See how this is, okay, see how there, okay, that's cool. So this basically tells you, so wait, I want to go to Part Studio 3. We're going to hide the stocks, hide the surfaces, and we're going to look at the draft analysis. Mold, split direction. Does it matter? Interesting. Right, but so here it's blue because it's all good. And then it's yellow here because we do have a 90-degree thing. But honestly, for something that thin, I guess it's fine. I don't know. I haven't seen really many videos about how you make molds. But it seems pretty important. Okay, but now that I feel like I know how to do it, I'm ready to buy the degasser, but I want to look up. Ooh, that looks good. What are ejector pins? I'm actually even more curious about something totally different, which is, let's just hide the stock. Hide the surfaces. What are these? I see these everywhere, but what are they? These little things? Oops. What are these pin-like things I see on many injection molded parts? Oh, really? They're surfaces for self-tapping? They're alignment and self-tapping. I see. Injection molding. Well, we could just read the Wikipedia, but injection molding bosses. Open topped cylinder. I mean, if you're injection molding that, then I guess when you determine, like, okay. Okay, so I understand the problem with having a negative draft angle because you can't get the part out. But for 90 degrees, what determines whether or not a vertical is okay to use? Ooh, I would actually like to look. I saw some molds where you like slide it out or something. I forget. Right, okay. Yeah, you basically just have to do some math, I guess. Highly polished molds. Oh, that would be interesting if we could quantify that with a load cell. Dude, take it to the next level. So basically, instead of let's see, you somehow fasten to the cavity and the core, right? And then you use a 3D print. You're using 3D printed molds in this case, and then you measure the force required to pull the thing apart. So you just measure that over time, and then you machine the cavity and core, and you see, is it less? Because it probably is less. That would be a very fun experiment. God, I really want to build. I really want to build that. That sounds so fun. Ejector pin. Because yeah, most of this stuff is ooh, actually I should download Fusion just so that we could start to do cam stuff. That was almost super scary. I almost leaked some shit, I feel like. I'm so glad I'm on Alright, let's just read the Wikipedia page on injection molding for a second here. What the hell? What is this British nonsense? Oh my god. Molding. Now that's interesting. This is from Wikipedia, and it states that it's specifically injecting molten material. But for something like silicone, that's not molten, right? Right? Oh, really? Huh. Oh, there's its own... Okay, so wait. What are the biggest uses of silicone molds? Oh, can you heat up silicone really hot? That's interesting. I didn't even think about that. So can you use silicone molding as... can you mold a mold, basically? You probably can, right? What happened? Protecting electronic coatings by encapsulating them in resin? That's interesting. Rubberized keypads. Yeah, so how did they... Okay, wait. Let's just look up on Wikipedia. And just see how to choose a silicone. That's an interesting thing. We sort of need to do that. Okay, so let's just... Okay, so now that we have designed a thing, let's... Oh, see, now that's interesting, right? Because... Wait, hold on, go back. Okay, so if you look at this mold, then you can see that they add these, and I wonder if we can... I wonder if we can do that. For the... I wonder if there's a way to add locator pins. When to use a two-piece mold. When can you not use a two-piece mold? All right, I'm gonna be right back. I gotta take a leak. Okay, so I didn't see any way to do the locator pins. So let's look at some of these examples. Dude, Smooth On? That company is crazy. Dude, this guy makes such high quality videos. Is that wood or polymer? That looks like polymer. Surface finish is too good. Yeah, it's definitely. Wow, look at the size of that drill bit. But he's doing resin casting. What is the definition of resin? A resin is a solid or highly viscous substance that is typically convertible into polymers. Okay, that checks out. I kind of want to just read this, but... So you can... injection molding of glass. There's a song by the Charlatans called Plastic Machinery. That's funny. Dude, actually, you know what would be funny is a band that's sole purpose is to make songs from like technical Wikipedia articles just so that they can claim space up here as advertising space. It's kind of a good idea. Because you can have the song just titled like that. Okay. elastomers. An elastomer is a polymer with viscoelasticity. Dude, I have got to learn material science. I do not know what this is. Confections. Most commonly thermoplastic. Yeah. Yeah, so you kind of have to do some manual post processing where you take this and you take this, and I mean it's a part like any other part, so you could just sketch on it, put a circle here, extrude this. Wait. Extrude this. Oh, you can extrude. That's interesting. I didn't know that. Remove up to next. And then if we go to Part Studio Assembly 1, why? I guess it doesn't update. I thought it does update. In any case, this is where you'd put some ejector pins, and then presumably we can just manually. I guess you need to do a little bit of work, because when you put in the locator pins, so let's just add 4 locator pins. So we're gonna hide this. We're gonna sketch on here. Draw a circle here. Yeah, 10 sounds good. Then let's make this 5 and this 5. And then we're gonna take this, extrude this by 5 seems fine, or 10. Okay, and then we want to circular pattern that feature across here. Okay, but now what you have to do is you have to do the same thing. So we're going to hide this and do this. And then we're going to make these like 10.3 or something. So you sketch on here like this. This is going to be 5. This is going to be 5. This is going to be 10.3 or something. And you extrude that, remove, what did I say, 10? So we'll make it like 10.2, I guess. Mainly you're trying to locate it horizontal. You're trying to locate it in X and Y and not really Z, because you already have a mating surface for Z that indexes there. So I feel like that tolerance isn't that important. But now we want to circular pattern this. It's a feature pattern. It's this extrusion, and then the axis of pattern is going to be that. So now we've added locator pins to the mold, and we've added a ejector pin thing. Not that we will need this. And I'm wondering how I'm actually going to do it. How would I do it when I actually pour it in? Because the thing is, I feel like it's going to seep through. With any 3D printed thing, the tolerance is not going to be tight enough where it's... how do you actually calculate whether or not it's going to seep through? This is so annoying. It's like the only option is regenerate. Okay, whatever. So, okay, so I designed a mold for basically just a cup. It's just a hollowed out, like a shelled out cylinder. So, it's it's just, that's what it is. And I created the mold in onshape, and I just added a cutout for an ejector pin, and I also added some locator pins that mate the cavity in the core. But what I'm wondering is, because I'm going to be 3D printing the molds most likely, or the core and the cavity. So not So, anyways, and for the ejector pin, how do I calculate? Oh, I assume that there's some way based on the viscosity of the liquid that you're going to be pouring into the the molding process. What kind of tolerance and fit you need between the ejector pin and the cavity to prevent it from seeping through. Oh, injection pressure. I didn't think about that. Injection pressure too. Hey, that's pretty small. Two thou? That's pretty. Dude, that's pretty. Yeah, so you kind of have to machine this because I don't think I get anywhere near that kind of tall. That's a tight tolerance for sure. Especially 5 times smaller than that. That's like 0.2 of a tenth. That's crazy. Oh, you can make the whole undersized and ream it. Honestly, though, a lot of this stuff is. Does silicone shrink? I know that plastics typically do, but what about silicone? The type of silicone. All right, let's read this. This is so we read some of this. We didn't really read much of it though. Can we please? There we go. What was it that I was looking into? It's not rubber. It's um. Oh, is it nylon? No, it's not nylon. What was I thinking of? Latex. Oh, it's gonna bring me the fucking stupidest thing. Okay, yeah, this is what I was thinking. Latex is really interesting because I didn't realize that it's basically natural. Just another example of synthetic biology. Thermosetting. Do you actually have to heat it? I don't know. I thought you didn't have to heat it. Dude, material science is so cool. I mean, it just happens that you can find all of these arrangement of chemicals that just do all the cool stuff that you want. Silicon rubber's over molded. Nylon housing. No, so why would they do that instead of machine a silicone button face? In order for the liquid injection molding process to occur, several mechanical components must be in place. Typically, a molding machine requires... Let's just look up silicone molding machine. It doesn't set fast enough, so they put it into the cavity and then like a press comes down. Okay. That's it. these are like baby bottles. How do they do multiple colors? That's cool. Wait. So much stuff just happened. Is that silicone? All right, okay, I feel like I've done this on stream before, but let's just look up silicone, because maybe we can get like kind of an intro on... Not that I know any chemistry, but, you know... Wow, dude, chemistry is so awesome, bro. I used to love chemistry. I've been thinking I gotta start building up my chemistry tooling so that I can do little experiments, because God, chemistry is so fun. Organosilicon and polymer chemistry. A silicone or polysiloxane is a polymer composed of repeating units of siloxane. Where R equals... Because, dude, there's so much symbolic... There's so much like computer algebra symbolic opportunities here. R is always some pattern. And it's like, you don't see it in biology. You don't really see it in physics. I don't know, maybe you see it in physics. I'm not a physicist. But chemistry, you always see patterns like this, where R equals an R. That's so fucking cool, man. Pattern matching, bro. Okay. So I don't even know how to look at stuff like that. But alright, there's siloxane. They're typically colorless oils of rubberless-like substances. Silicones are used in sealants, adhesives, lubricants, medicine, cooking utensils, thermal insulation, electrical insulation. Silicone oil. Caulking is made of... Really? I'm not gonna understand this. I want to just more. It would be cool to synthesize it. Whoa. It forms glass? Okay, the properties of silicones: low thermal conductivity, low chemical reactivity, low toxicity, thermal stability, hydrophobic, adheres well to others. Oh, so it's specific in its whatever mechanical. I don't know how you say that. It's fancy. Does not support microbiological growth. That's interesting. Ullman's Encyclopedia of Industrial Chemistry. I didn't realize that you can keep it as a liquid. Whoa, you can 3D print silicone? The hell is pot life? Oh wait, was that company? Dude, that was that company that put it in gel. There was this company I saw on Instagram. They basically have this big gel and they deposit. That's so cool. There we go. Here we go. Mold making. Two-part silicone systems are used as rubber molds to cast resins, foams, rubber. See, I wonder how these are these cast? Are they molded or do they do some other process to make them? Oh, maybe you just let's see. If you look at this, let's see. Could you go down lengthwise to for the part off surface? You would need to flex. That's probably a better surface choice because you would need to flex only these little things, but you wouldn't have to like flex the whole thing. Yeah, right. I want to see that. But how do they do it? They have to sculpt it, right? God, that's so scary. I don't need to look at that, bro. Why is it always the circular compounds that seem to be toxic? Okay. So now I guess now we need to learn about. So let me just do this really quickly. Make sure that. Yeah, I figured. Okay. I like trains. I don't know why they're recommending me that. Okay, so uh so how does a vacuum pump work? Okay, so this is what I was going to get is the basically this. Oh my god, dude. Why do they... Can I just... Fucking Jesus. Let me live my life. Okay, so basically the pump rate, I guess that was what that is, cubic feet per minute. I need to understand the mechanics really behind a vacuum pump because I don't actually understand how... I don't understand really how pumps work at all. Single stage pump design for higher and more stable ultimate vacuum. So it says vacuum level 40 microns. Pump oil. So what does that mean? 40 micron. What does that actually mean? Okay, single stage pump. Okay, I feel like that's self-explanatory. Free air displacement. Okay, it's the volume of air that the pump can move per minute at atmospheric pressure. Okay, great. But presumably that gets lower as the pressure goes down. FAD probably gets lower once the pressure inside the tank starts to get lower, right? Like it's not gonna always be. They just rate it based on one ATP or one A whatever it's called, 1 atmosphere. God, sometimes it's so laggy. Yeah, so do they give you graphs of like an example of... Because it'd be nice to get a graph of the flow rate over time. Okay, this is the lowest. Okay, yeah. So the like, for example, Sam Z-Loofs, I think went to like 1,000 times lower of a vacuum than this. What cool things can you do at 40 microns? Because you could probably hook this up to anything, right? Like, is it constrained in the volume that it can handle or no? It's probably more so whatever you're hooking it up to has to be sealed enough that you could actually get it down that high. Because if there's a leak in it, then you're just going to be pulling nothing. You can remove dissolved gases from solvents, oils, and even adhesives. Yeah, so optical coatings. The boiling point of water is reduced. Okay, yeah. Ugh, I want to do that so bad. Physical vapor deposition. Yeah, it's so awesome. I don't know how you could keep I don't know how you could keep that thing hot though. I gotta go take another leak. But yeah, so this is what we're thinking about doing. Now we got to learn about how the vacuum actually, how the pump actually works. Yo, guys, I looked in the freaking mirror. I got like a rash on my face, dude. What the hell is that? That's no good. So anyways, I'm gonna go take a shower. We'll learn about how vacuum pumps work later. But really weird. I don't know what happened. There's just like a rash on my face. Alright, let's just... Alright, it's not urgent. Let's figure out how do vacuum pumps work. By the way, I'm trying to keep the amount of external. I'm trying to make the proportion of me talking on my streams to the proportion of any other audio very high. So I'm basically keeping everything muted and it's all just captioned, because then when I do word frequency analysis and distributions, it's basically just me talking, which is what I want, because I really don't want anything else. Standard AC motor? And that drives this. So that's connected to the road. Okay, wait, hold. Okay. Okay, we don't need a freaking lesson on how AC motors work. What is there a Wikipedia page just for vacuum pump? What? Actually, vacuum pumps are very interesting. Dude, Greek fire's fucking awesome, bro. Nah, that's sick. That's sick. Oh, damn, bro. That's so sick. The height of the column is then limited to the maximum weight that atmospheric pressure could support. Dude, Wikipedia articles like this are so cool. The Magdeburg Hemispheres experiment. Dude, the study of, I mean, if you think about it, okay, this channel is expanding into the study of light, the study of gases. You know, if you just simplify, the study of gases has a very rich history. So it's like all we're trying to do is spray paint, but there actually is years and years and years of, cool shit behind it. 2-cylinder pump. Rack opinion. Vacuum pump history. Is there a history video? How the Inquisition led to the vacuum pump. Oh, I want to watch that video. I'm not signed in though. Very fun. Very fun. Okay. Dude, it's so cool. It's just like these scientific records. Um, 40 microns means what exactly? It'd be cool to make a vacuum tube. Oh, okay. It's in. It's in millimeters of mercury. So we can go like 100 times lower than this. What is the world record for lowest pressure? Wait, hold on. Let's do this. What is the world record for the lowest pressure? Whoa, that is super low. Yeah, I'm talking about the lab ones. Dude, that is crazy. Oh. I guess, yeah. I guess if you're building a particle accelerator, you kind of do need to... rough it. Oh, dude, it's like machining, bro. That's crazy. You got roughing pumps. You got the turbo... Turbomolecular pump. How does it work? Pumps can broadly be categorized into 3 techniques: positive displacement, momentum transfer, and entrapment. This shit is crazy. Use high-speed jets of dense fluid or high-speed rotating blades to knock gas molecules out of the chamber. It's actually crazy that that's how you can do it. Okay, in any case, this is what we did. I'm going to go take a shower. This is what we built. Oh, there we go. There, it finally updated. So we got our... So this is a basic mold for a little cup. And we got locator pins. We got a, whatever it's called, an ejector pin. And then we got the mold itself. And if you look at the radius of this, it's... diameter is 44. Diameter is 50. Yeah, that's right. Cool. So that is what we did today. We made a mold. You can go back and see it for yourself. We made a mold. Then we failed to make a mold here where we had a taper. We had a taper which was an overhang. And I couldn't get this one to work, but I was able to get this one to work, which is the opposite, which is the positive draft angle. And this is probably going to be, this, if you look at the mold, would be the easiest one to take out of here because it's just going to slip out of here. So then when we did our draft angle analysis, you could see, okay, look, they're all positive 20. So we're all good. Anyway, so basically that's how you make molds in Onshape. I think I finally sort of got the hang of it. Dude, why does this thing keep recording? Damn. All right.